Physics normally treats space-time as the stage on which reality unfolds. But what if space-time itself is not fundamental? What if it is only a condensed phase of something deeper?
That right there is the million-dollar question for today.
It really is. Welcome to the deep dive, everyone. If you are joining us today, you are probably the kind of person who loves that feeling of having a paradigm totally shifted.
Oh, absolutely.
Yeah,
But ideally without having to wade through a mountain of impenetrable jargon to get there.
exactly. No info overload today. That is our mission. We are going straight to the frontiers of theoretical physics to explore a framework that completely reimagines the structure of physical reality.
It is a fantastic mission to have. And honestly, there is no better starting point than the source material we are working from today.
Yeah, we are looking at a really fascinating set of excerpts from a 2026 position paper. It's titled The Quantum-Condensation Interpretation of Emergent Spacetime.
Written by Lev Nemotin, PhD. And for those listening who might follow the bleeding edge of science communication, you probably know him.
Right, he is the creator of the Uncompressed Thinking channel.
He is. He spends a lot of time exploring those blurry boundaries between physics, AI, and human knowledge.
And he has a real knack for proposing these interpretive frameworks that are intended to stimulate discussion rather than just present, finished, closed-loop theories.
Which actually brings up a really important piece of housekeeping before we jump into the deep end here. I want to set some clear expectations for you listening.
Always a good idea.
Our goal today is not to teach you advanced mathematics or to present some finalized, peer-reviewed theory of quantum gravity.
No heavy math today, promise.
Right. And that isn't what Nemotin is trying to do with this paper either. He presents this strictly as an interpretive structure.
So like a conceptual map.
Exactly. It's a tool. It's designed to establish a disciplined vocabulary, to stimulate new ways of thinking, and to help organize how we discuss emergent spacetime, matter formation, and quantum entanglement in the future.
Okay, let's unpack this. To really appreciate how radical this conceptual map is, we should probably start by reminding ourselves of how the standard picture of physics works today, just to set a baseline.
That makes sense.
Right now, our understanding of the universe relies on two incredibly successful pillars. On one side, we have quantum field theory.
Which gives us the language of the microscopic, particles, excitations, fundamental forces interacting.
Yeah. And then on the other side, we have general relativity, Einstein's masterpiece.
And that gives us the language of the macroscopic world, curved space-time, gravity, the causal structure of the universe.
And both of those frameworks are brilliant at what they do. I mean, they have passed every experimental test we have thrown at them.
They really have. But they share a massive, almost unspoken assumption. They both treat space-time, the speed of light, and matter as the fundamental background.
They assume the stage is already built. The lights are on, the rules are set before the play even begins.
Precisely. Modern physics describes the behavior of matter and radiation wonderfully once that stage is in place. But it leaves a much deeper structural question completely open.
Which brings us to the core intuition of Nemotin's entire framework. What if space-time is not the bottom layer of reality?
What if space-time is actually emergent?
Yes. The paper introduces this idea of a pre-geometric substrate. And honestly, this is a massive conceptual hurdle to get over.
It is, because we are talking about a fundamental domain that has no geometry.
Right. There is no distance, there is no duration, no space, no time.
But if there is no space and no time in this substrate, you might be asking, how can anything exist or happen there at all?
It sounds like we are just describing literal nothingness.
It does sound like nothingness if you are thinking in purely spatial terms. But that is exactly the habit this paper wants us to break.
Okay, so how should we think about it?
When we say pre-geometric, we mean that the very concepts of measurement, metric structure, and physical separation simply do not apply at that foundational level.
So it's not empty, it doesn't have rulers or clocks.
Right. If you are listening to this and trying to picture a universe without time or distance, you are not alone. It is totally counterintuitive to how our brains evolved to see the world.
It really is.
But think about it like the underlying code of a video game.
Oh, I like that. Let's explore that video game idea.
In the code of a game, the substrate, if you will, two characters might be right next to each other in a line of data or associated through a specific mathematical variable.
But there is no actual distance between them in the code.
Exactly. It is just a network of mathematical relationships. But once the game engine processes that code and renders a 3D environment,
those two characters might suddenly be placed miles apart in the virtual game world.
Yes. The 3D space is an emergent property of the underlying non-spatial data. The substrate isn't empty nothingness. It is the rich network of relations. It just lacks the geometric architecture of space and time.
So the obvious question then is, how do we get from that unrendered code to the 3D world? How do we get from a spaceless, timeless substrate to the incredibly structured geometric universe we actually live in?
The framework describes this transition using a very specific phrase. It calls it substrate condensation into spacetime.
Condensation. Now, when I hear that word, my mind immediately goes to high school physics class.
Sure, most people's do.
Are we talking about literal condensation here, like water vapor cooling into liquid droplets, or, I don't know, creating a Bose-Einstein condensate in a super chilled laboratory?
It is a great question, and we need to clarify what those things are to understand what the paper is actually saying.
Right.
In a lab, a Bose-Einstein condensate happens when you cool certain gases to almost absolute zero. The atoms lose their individual identities and clump together into a single quantum state.
They act almost like one superatom.
Exactly. Imagine an orchestra where every single musician suddenly starts playing the exact same note at the exact same time, losing their individual melodies to become one unified wall of sound.
Wow. Okay, so it is a literal physical phase change of matter.
It is, but that is not what Nemotin is describing for the substrate.
Okay, good to know.
The paper is very careful to clarify that point. We shouldn't imagine the substrate as a conventional quantum fluid getting physically chilled. The word condensation is being used as an interpretive bridge.
Got it. So it is a metaphor.
It is a metaphor that captures the intuition of a transition from a diffuse, less tangible, non-geometric state into a highly structured, stable, and geometric regime.
It describes a phase-defining event where causal order, physical geometry, and a finite signal speed suddenly become physically meaningful.
Exactly. It is an organizational event, the rendering engine kicking on and creating the stage.
And that leads us perfectly into how this framework maps out the physical world, because it provides a very clear directional hierarchy of emergence.
Yes, it does.
If you were drawing this out on a whiteboard, it flows sequentially like the substrate, leading to space-time, leading to matter, leading to entanglement.
Let's pause on that sequence for a moment, because this violently reorganizes our common sense.
It really does turn things upside down.
In ordinary, everyday discourse, we think of matter as the primary building block of reality.
Right, the whole atoms are the basic building blocks of the universe idea we all learned in school. We just assume the physical stuff is the foundation.
We think, okay, you have particles, they occupy some void of space, they interact over time, and they aggregate to create the planets, the stars, everything. We treat matter as the raw material.
But in this framework, matter is a secondary emergence.
Stable particles in quantum fields are not the raw material that spacetime is built out of. Spacetime has to emerge first.
The stage has to be built.
Yes. The condensation into a spacetime phase has to happen to even create a regime where concepts like localization, field persistence, and interaction have any meaning at all.
The paper uses the specific example of an electron to make this concrete, which really helps ground this.
The perfect example.
Normally, we think of an electron as a fundamental excitation of a quantum field, basically a stable ripple in an underlying energy field. But this framework asks a prior question. Under what conditions does an object like an electron even become a meaningful entity?
What's fascinating here is how it entirely shifts the philosophical burden. We go from asking the age-old, somewhat unsolvable question of how did matter come out of nothing?
Which always hurts my brain.
Right, to asking a much more structural, productive question. How did stable particle identity become possible within a condensed spacetime regime?
Because an electron isn't just popping out of nothing in some naive, magical sense. It has highly specific traits.
What physicists call quantum numbers. Things like its specific mass, its negative electrical charge, its spin.
Yeah, and those traits require a framework to exist within. The spacetime phase must condense first to create the specific geometric environment where charge, mass, and stable quantum numbers can be defined and sustained.
Matter formation, including stable particle species like the electron, is just the development of structured excitations inside that newly available, highly organized geometric environment.
You literally cannot have the actors until you build the stage.
And this framework gives us a disciplined vocabulary to talk about that stage construction.
So let's talk about the rules of that stage, because this is where the paper really pushes you to question your fundamental assumptions. Specifically, the assumption regarding the speed of light.
Yes.
In standard relativistic physics, the speed of light, which we represent with the letter c, is the deepest, most unbreakable rule of the universe. It is an absolute fundamental constant of reality, the ultimate cosmic speed limit.
It is. But in the quantum condensation framework, the speed of light is treated differently.
How so?
It remains fully real and fully binding, but only within the emergent spacetime phase. It is not necessarily the deepest feature of all reality.
Instead, it is a defining property of the condensed regime.
Exactly. It comes into existence with the condensation of spacetime itself.
To really drive this home, the paper walks through an amazing thought experiment. I want you, the listener, to imagine a counterfactual universe for a second.
It's a great thought experiment.
What if the speed of information, the speed of light, were not a finite limit? What if the speed of information were infinite?
If you take away that finite speed limit, the entire foundation of modern physics essentially collapses.
It does. And the paper breaks down exactly what would happen in 3 specific consequences, which really highlight how dependent our physical reality is on that finite speed limit.
The first consequence concerns simultaneity.
Right, the idea of whether 2 things happen at the exact same time.
Exactly. In Einstein's relativity, simultaneity is relative. If you are standing on a train platform and lightning strikes 2 trees at the same time from your perspective, a person on a fast-moving train passing by will actually see one strike happen before the other.
Because the light takes a slightly different amount of time to reach them.
But if information could travel instantaneously, if the speed of light were infinite, that relativity of simultaneity would completely vanish. Every observer, no matter how fast they were moving, would agree on a single, absolute, universal time.
We would revert straight back to classical Newtonian mechanics.
We would. And consequence number 2 involves transformations. All the mind-bending stuff from relativity disappears.
If you have ever watched a sci-fi movie where a spaceship travels near the speed of light and the crew ages slower than the people back on Earth, that is time dilation.
There's also length contraction, where objects physically compress in the direction they are moving.
And those effects are dictated by mathematical rules called Lorentz transformations.
Right. And those Lorentz transformations only exist because every observer, regardless of their own speed, has to measure the exact same finite speed of light.
That finite limit forces space and time to warp and bend to keep the speed of light constant.
But if you remove that finite constraint, the paper explicitly notes that we would be reverting Lorentz transformations back to older Galilean ones.
Let's pause and define Galilean transformations for our listeners just to make sure we are all on the same page.
Think of Galilean transformations as everyday, intuitive physics.
Like throwing a ball.
Exactly. If you are standing on a train moving 50 miles per hour and you throw a baseball forward at 50 miles per hour, an observer on the ground sees that baseball moving at 100 miles per hour. You just add the speeds together.
Space and time are completely independent entities in that view.
They don't group to accommodate a speed limit. By imposing a finite speed of light, the space-time phase forces those independent entities to weave together into the complex relativistic space-time we actually observe.
And the third consequence is perhaps the most profound of all because it concerns gravity.
This is where it gets really strange.
In general relativity, gravity isn't just an invisible magnetic force pulling things through an empty void of space. It is the literal curvature of space-time itself, produced by mass and energy. Heavy things create dips in the fabric of the stage.
But the mathematical equations that describe that curvature explicitly use the speed of light to couple the matter to the geometry of spacetime.
So if the speed of light were infinite, that coupling would vanish.
Which means spacetime curvature loses all physical meaning. Gravitational waves, those ripples in spacetime we recently detected from colliding black holes, would cease to exist.
Gravity would just revert to instantaneous action at a distance.
It would be like invisible, instantaneous strings pulling planets around, rather than planets rolling along the curves of spacetime.
The takeaway here is profound. When you put all 3 of those consequences together, you realize that the familiar relativistic universe you and I inhabit, with its light cones and causal limits and curved geometry, is just a limited phase.
The emergence of spacetime is simultaneously the emergence of limitation.
When the substrate condenses, it introduces separation, delay, locality, and finite transmission. Those limitations are what makes stable matter and localized observers like us possible.
But they are still limitations, though I do want to make a quick conceptual hygiene note here.
Oh, good idea.
I know it is so tempting to hear all this and think, oh, I get it, things move at infinite speed down the pre-geometric substrate.
Yeah.
But the paper explicitly warns against saying that.
Right, because if we are sticking to our definitions, you cannot have speed if you do not have distance and time.
Speed is literally just distance divided by time.
Since the substrate has no geometry and no duration, applying the concept of speed to it is a categorical error. It is like asking what color the concept of algebra is. It just doesn't apply.
Precisely. The paper suggests using much more disciplined terminology. Instead of infinite speed, we should speak of things like global informational accessibility.
Or non-local adjacency.
Right. Going back to our video game metaphor, it means the substrate allows for relations that simply aren't constrained by space-time separation, because spatial separation hasn't been rendered yet.
Here's where it gets really interesting. Because if you have this deep underlying substrate where everything is non-locally adjacent, where everything is essentially touching the code, and then a space-time phase condenses on top of it and imposes these strict limits of physical separation and finite signal speed.
That perfectly sets up a new way to understand one of the greatest mysteries in all of physics.
Quantum entanglement.
It is a brilliant synthesis. The paper connects these ideas by forming a conceptual triangle: finite signal speed, space-time geometry, and quantum entanglement.
Usually, entanglement is presented as this incredibly spooky, weird anomaly. You have two particles that interact, they become entangled, and then you can separate them by miles or even light years.
But if you measure the spin of one particle, the other instantly assumes a corresponding state.
It seems to violate the very rules of space-time we just talked about, acting like they are still connected across vast distances with zero time delay. Einstein famously hated this and called it spooky action at a distance.
And in a purely local, relativistic space-time framework, it is an anomaly. It is a paradox. But within the quantum condensation interpretation, entanglement actually makes perfect intuitive sense.
It is reframed entirely. Walk us through how the substrate solves the spooky action.
Because space-time is just a condensed phase, entanglement can be viewed as a trace or a remnant of the deep, non-spatio-temporal connectedness that has always existed in the substrate.
Before condensation, there was no physical distance separating those systems.
When the space-time phase condenses and imposes locality and finite speed causal structure, those entangled systems retain a signature of their original, deeper relationship.
It's like those two characters in the video game. They are rendered miles apart on the screen, so to a player inside the game, it looks like magic if they perfectly mimic each other instantly.
But if you look at the underlying code, you see they're tied to the exact same variable. The connectedness was there first.
That is a perfect way to visualize it. It softens the entire mystery of quantum mechanics for us.
It is not that these two separated particles are somehow secretly communicating faster than light through physical space. It is that the emergent space-time phase remains partially transparent to the deeper level it arose from.
The separation we see is just a property of the emergent phase, not the fundamental reality.
The puzzle stops being, why do these separated things act like they are magically connected? And becomes, why does this deeper substrate-level connectedness present itself inside our condensed spacetime in such a highly restricted, mathematically specific way?
It stops looking like a glitch in the matrix and starts looking like architectural evidence of the layers beneath us.
It is a profound shift.
Oh.
It honors the absolute success of general relativity and quantum field theory within their specific domains, while providing a rigorous way to talk about what might lie beneath them, without falling into lazy metaphors or confusing new concepts with old, discarded physics theories.
So what does this all mean?
I think if we zoom out and look at the big picture, the massive value of Lev-Nimeton's framework here is that it gives us a disciplined vocabulary.
It forces us to stop blurring space-time, matter, and quantum states all together into one messy soup. It organizes them into a coherent, directional sequence.
Substrate first, space-time second, matter third.
And entanglement as the breadcrumb trail leading back to the start.
As a reminder to you listening, this is an exploratory tool. It is not a finalized mathematical theory that you are going to see replacing university textbooks tomorrow.
But if this conceptual map sparked something for you, if you enjoy exploring these bleeding-edge interpretive structures, I highly encourage you to seek out the original 2026 position paper.
And definitely check out more discussions on Lev-Nimeton's uncompressed thinking channel.
It is the perfect playground for anyone who wants to push the boundaries of how we conceptualize reality.
And as we wrap up, I want to leave you with a thought that builds on the paper's directions for future research. It is something to mull over long after this deep dive ends.
Let's hear it.
If the very identity of a stable particle like an electron is just an emergent pattern, a stabilization that only happens because of the specific way our spacetime phase condensed, Could different phases of condensation yield entirely different stable realities? If the foundation of our reality is just one frozen phase, what else might be waiting to thaw?
What a phenomenal question to end on. Thank you so much for joining us on this deep dive. Keep questioning the stage, and we will catch you next time.